Mbakwa phosphate. You are welcome to Mbakwa phosphate. Welcome to Mbakwa Phosphate Academy. I'm your brother Mbakwa Jonas Dalton, popularly known by my student as Mbakwa Phosphate. I'm sure you must have heard about Mbakwa Phosphate before. You are welcome, dear student. We can teach you online at any time that you are free. Contact us at 679953185, 6644632, 57 6778325 Email us mbakwaphosphate@gmail.com. Are you facing difficulties in chemistry, physics, biology, mathematics, etc.? Mbakwa phosphate is the solution. Do not forget to subscribe. Subscribe to the channel at, here is the subscription button. Subscribe here. Now, can you see the person on the screen? I'm sure you must have done chemistry for some years now. At least maybe 1 or 2 years. Can you identify the person on the screen? This person on the screen is a great scientist. Great scientist. I want you to just take down your pen, and write down the name and think whether you can know this scientist. Have you heard of Dalton's atomic theory before? Do you know John Dalton? Here is John Dalton. This is John Dalton. This is a great scientist. John Dalton, 1766 to 1844, was an English, scientist. He studied the atom extensively, and he brought some, proposal or ideas about the atom. Some of his proposals were correct, perfect, because those proposals were backed by so many convincing experiments. He brought proposal as all matter is made of tiny particles called atoms. He brought proposal of atoms cannot be subdivided. But this is interesting. Today we will be talking about the atom, and we'll be looking at the subatomic particles. But you can see John Dalton saying that atoms cannot be subdivided. Now we'll be looking at subatomic particles. So you're trying to see this to convincing, contradictory statement here. John Dalton was saying that an atom cannot be divided in Dalton's atomic theory, but with recent discoveries, we understanding that an atom can be divided into 3 subatomic particles, and we'll be looking at the protons, the neutrons, and the electrons. Look at John Dalton. But this man is, it's incredible. He did a lot of work in chemistry. He worked perfectly. He did quite enormous work. He was so convincing because he carried out a number of experiments. In one of the statements of Dalton atomic theory, he also said that all element is made of, one kind of atom. Yeah, that statement was correct. All element made of one kind of atom. An element is a pure substance that's made of only one kind of particle. An atom, one kind of atom. So this statement was perfect. He also said atoms of the same element look alike in every, aspect. But this statement is also, with recent discovery, some kind of contradictory. Where in the other lesson, I'll be talking much about Dalton's atomic theory and the modifications. But this is just to build a background of what we'll be talking today about, because we'll be talking about the composition and the structure of the atom. And so this background was very important for us to note. Composition and structure of the atom. Now, I want us to note that an atom is made up of 3 subatomic particles. Yes, 3 subatomic particles. We have the electrons. Let me change my ink so that it becomes clear. We have the electrons. We have the protons. And we have the neutrons. So, how are these subatomic particles arranged in an atom? Imagine this is the structure of the atom. Inside the small and dense portion of this atom, we have what we call the nucleons. And these nucleons consist of 2 subatomic particles. We have the protons and we have the neutrons. And this region in an atom has a name. It is called the nucleus. It is called the nucleus. So inside the nucleus, we have the nucleons. The nucleons consist of the protons and the neutrons. Then as we begin to move out of the condensed and massive center of the atom, outside the atom, we are going to have regions which we have the high probability of finding an electrons. When I will be working with the advanced level, I will avoid to talk about shells. But this lesson is for my ordinary and intermediate students, so I'm comfortable to say that we have the electron shells. The electron shells. The electron shells, we can see that electrons are moving on the shells. Electrons are constantly moving on the shells. Yes. Now, I want you to note that when I come with the advanced level, you are an advanced level student looking at this video, I would prefer to use orbitals, because I would define an orbital as a region around an atom where there is a high probability of finding an electron. Because we do not have exact position in an atom where we can pick an electron, but we have regions around the atom where there is a high probability of finding an electron. And in that case, I will be talking about the S, I will be talking about the P, I will be talking about the D orbitals, the F orbitals, etc. But for my intermediate and ordinary level students, I will be looking at the shells. And so, we will look at the atom to have the K shell, the M, the L, the M, and the N shells. We will see this in our next video when I will be looking at the electronic configuration, the arrangement of electrons around an atom. Here is the structure of the atom. We have the nucleus, which carry the nucleons, protons and neutrons. We have the electrons that is constantly moving around the nucleus as planet moving around the sun. And I said at the advanced level, orbitals will be used in place of these shells in an atom that carry electrons. We'll be comfortable to use the SPDF orbitals. The subatomic particles were discovered by some great scientists. Remember, we have already seen that an atom is no longer thought to be indivisible as our great scientist John Dalton had said, but instead the atom has been seen and proven by experiment to be divided into 3 subatomic particles. And we have seen the protons and the neutrons in the nucleus of an atom, and we have seen the electrons moving around the nucleus as planets moving around the sun. I will be asking you a question before we get there. Why do you think that? What is the force that keeps the electrons attached to the nucleus? That is already taking us to charge, the charge of the subatomic particles. Who discovered the electrons? Can you just write down the name of the scientists that discovered the electrons? Can you say with me, John Thomson, 1887, discovered the electrons? J.J. Thomson, 1887, discovered the electrons. This is J.J. Thomson. Yes, he is working in one of those laboratories in those days. You can see how busy this great scientist was. Look at J.J. Thomson. Here he is. This is J.J. Thomson in different occasions. He discovered the electrons. He's a powerful scientist. Look at the experimental setup. I understand that this this lesson is for my ordinary and intermediate students, but I just wanted to see the experimental setup. In my lesson with the advanced level student, I will be looking more of this experiment, discovery of the electrons by J.J. Thomson, cathode ray tube experiment. You have the fluorescent screen. I will not talk much here to my students, but if you're interested to know that, you check my video on the discovery of the electrons by J.J. Thomson, cathode ray tube experiment in the other lesson. Who discovered the protons? Is Ernest Rutherford, 1920. Ernest Rutherford discovered the protons. Ernest Rutherford, 1920, discovered the protons. Can you see Ernest Rutherford? These are great scientists. Ernest Rutherford. In 1911, he was the first to discover that atoms have a small charged nucleus surrounded by largely empty space and are circled by tiny electrons, which became known as the Rutherford model or planetary model of the atom. Who discovered the neutrons? James Chadwick, 1932. James Chadwick, here is he. These experiments are discussed by Mbakwa Phosphate for the advanced level students. They can always check this experiment. If you're interested, you can equally check this experiment. Don't forget to subscribe to our channel so that new videos, new lessons, when discovered, you are going to be able to get them. An atom, definition of an atom. An atom is the smallest particle of an element. Is the smallest particle of an element that can take part in chemical reaction. That can take part in chemical reaction. So we have seen that an atom is made up of 3 subatomic particles, the protons, the neutrons, and the electrons. Characteristics of subatomic particles. subatomic particles, we can be interested to look at the charge that they carry. We can be interested to look at their mass and also their location. So the first subatomic particles we have is the electrons. The electron has a charge of -1, a mass of 1/1840 atomic mass unit. So it is having a small mass, negligible mass. That's why when we come to the importance of the electrons, we will observe that the electrons is not going to contribute that much to the mass of the atom. Location: the electrons located on the electron shells. The next subatomic particle is the protons. The proton has a charge of +1. You can already now see the reason why an atom is going to exist, because the electrons are found on the shells and they are negatively charged. Now in the nucleus, the protons is positively charged, and therefore there's an attractive force that keeps the electrons moving around the nucleus on the electronic shells. That electrostatic force of attraction helps to keep the atom existing. The mass of the proton is 1 atomic mass unit. So the proton contributes to the mass of the atom. Can you imagine that? And of course, we have seen in the structure of the atom that the nucleus, the proton is found in the nucleus of the atom. The last subatomic particles we are interested in seeing is called the neutrons. The neutron has no charge, 0 charge. It's neutral from the name neutrons. It's neutral. And it could equally contribute to the mass of the atom as it has a mass of 1 atomic mass unit. It has a mass of 1 atomic mass unit. I will say that it is equally located. We can get the neutrons in the nucleus. Now, if I ask you, what is a neutral atom? What do we call a neutral atom? An atom is going to be neutral. For example, sodium. We are going to have 11 protons . Alright, so we have seen the atom. Okay, so this is where we are. Now, for a neutral atom, we expect that if an atom must be neutral, then it must have the same number of protons to the same number of electrons. If this is sodium, it has 11 protons and 11 electrons. This sodium is neutral. Now, if I take sodium now, imagine when sodium lost 1 electron, it becomes positive. The proton has not been touched. The number of protons still remain the same, 11 protons, but in this case, we have but 10 electrons. You see that if you take 11 minus 10, it is going to give you 1 protons, which is the positive one that we have here on the charge of the atom. If I have magnesium 2 plus. Magnesium is number 12. You see that the proton has not been touched. It still has 12 protons, but in this case, it has but 10 electrons. So there is 2 protons more than the electron that gives the charge of +2. That is what we call a neutral atom. We want to look the electrons and see how the electrons is going to help us in an atom. What is the use of the electrons? Let me arrange my mouse. How is the electron important to us in an atom? The first thing I want us to note about the electron is that the electron is negatively charged. The electron is negatively charged. The next thing that I want us to see, what we have already seen before, but for emphasis, is that they have a negligible mass of 1 over 1,840, that of the atom, of a proton, or that of the neutrons. The next thing I want us to see about the electron, which is very important, is that they move around the nucleus in shells. They move around the nucleus in shells or orbit. Remember the shells where we have the electrons? Yeah. They were moving around the nucleus in shells. We call these shells, and also, or another person can decide to call it orbit, just like a geographer will call that. One of the things we also need to note about the electron, which is very important to us, is that they determine the size of the atom. They determine the size of the atom. Let me explain this. Look at hydrogen. Hydrogen has only 1 electron. So we expect hydrogen to be written like this. Now look at sodium. Sodium has 2 electrons that will occupy the K shell. They will equally have 8 electrons, which is going to occupy the L shell, and then the 1 electron. If we want to look at the size, which one is larger? Of course, sodium with 11 electrons is going to have a larger size than hydrogen with only 1 electron. 1 electron. Another thing that I want us to note about the atom, forget about the long line that just appeared. Another thing that we want to note about the atom here is that these electrons that is found on the shells or on the orbits of an atom, the electrons are the particles in an atom that take part in chemical reaction. When we will come to the next lesson, which we will look at the electronic configuration of at least the first 20 elements of the periodic table, you will observe that when we write the electronic configuration, the last electron on the last shell, like sodium here, will have 2, 8, 1. This 1 electron is called the valence electrons. It's called the valence electrons. This 1 electron, which we call it the valence electrons, is going to participate during chemical reaction. So what takes part during chemical reaction is electrons, not the protons in the nucleus, nor the Neutrons, it is the electrons that take part during chemical reactions. They will either be shared in the case we'll be talking about covalent compounds, and of course either in covalent molecules or covalent compounds, or they will be gained. When they are gained or transferred, in this case the compound will not be covalent. In this case the compound will be said to be ionic. Ionic. The ionic compound will be consisting of two sets of atoms. We have the metals and the non-metals. For example, sodium chloride is formed from sodium and chlorine. So you see here the sodium will lose one electron, which will be accepted by the chlorine atom, and then when the chlorine atom accepts, they will give rise to sodium plus and chloride minus. This is an ionic compound. What caused this compound to be formed is the number of electrons on the valence share of each atom of the element. So you need to take note that the electrons will be very responsible for chemical reactivity in an atom. If you are enjoying the lesson, consider subscribing, consider sharing it with your friends, and tell them about Backward Phosphate Academy. The protons. How is a proton important to us? Number one, we have already seen that the electron is negatively charged, so the proton will be positively charged. Positively charged, and they are situated in the nucleus. We have seen that before. We also need to remind ourselves that the protons are quite heavy compared to the electron. That's why we say they have a mass of 1 atomic mass unit. So they contribute to the mass of the atom. Contribute to the mass of the atom. Take note. Contribute to the mass of the atom. Take note. The next thing about the protons, which we have to note, is that they are used to characterize. They are used to characterize an atom or an element. Since an atom of an element has a fixed number of protons. An element, as we are going to see, can be written as X. Here we have Z. And here we have A. This A is called the mass number, which is equal to the number of neutrons plus the number of protons. And the number of protons here is Z. And Z here is called the atomic number. It is this atomic number that we use to identify an element on the periodic table. Just like I explained that in Dalton's atomic theory, he did not make provision for isotopes, existence of isotopes. But we see that chlorine 3517 and chlorine 3717, they are isotopes of the element chlorine. One may also say that these are atoms of the same element. It is the atomic number 1717. So the atomic number in an atom is very important. And this atomic number is what we call the proton number, the number of protons in the nucleus of one atom of the element is called the atomic number. Make sure you look at my video on atomic number, mass number, isotope, isotopy, and electronic configuration, which is one of our videos that is released. You can check that out for clarification. If you take the element fluorine, fluorine is number 9 on the periodic table. If you take the element sodium, sodium is number 11. If you take the element magnesium, magnesium is number 12. If you take the element aluminium, aluminium is number 13. You see that what is making us to know that these are the position of these atoms is nothing else but the number of protons, which is called the atomic number. We want to look at the last thing we have for today's lesson, which is the number of neutrons. The number of neutrons. How is the neutrons important? How is the neutrons important to us? As a chemist, how is the neutrons important to us as a chemist? Number one, they are electrically neutral. They are electrically neutral particles. And they are neither positive nor negative. That's why we explained that the neutrons has a charge of 0. They equally have a mass of 1 atomic mass unit, just like the proton. So the neutrons happen to contribute to the mass of the atom. They will contribute to the mass of the atom. Interestingly. So the protons and the neutrons, which are found in the nucleus of one atom of the element, will contribute to the mass of the atom. Now you imagine that. They have a mass, a charge of 0, neutral, located in the nucleus of an atom, and they do not take part in chemical reaction. So how are they very much important to us? Now I want to explain this. We would have expected that if we have a proton in the nucleus which is positively charged, another proton here which is positively charged, then if you bring these two protons together, we expect repulsion between them. We expect repulsion between them. So if there is constant repulsion between protons in the nucleus, repulsion between proton in the nucleus, then we will not be talking about an atom. But how is the neutron going to help here? The neutron comes in between. It comes in between the protons. Given that they are 0 in charge and neutral in charge, they now separate the protons so that the protons no longer exhibit repulsion. Neutrons come in between the protons, thereby bringing what we call stability. Can you say with me, stability in an atom? Bringing what we call stability in an atom. It brings exactly what we call stability in an atom. The neutron is so great. We also will note that if I take a prominent element, chlorine, chlorine is going to have 2 isotopes. We will have chlorine 3517 and chlorine 3717. If I look at the number of neutrons here, it will be the mass number A minus the atomic number Z. So we are going to have 35 minus 17, which is going to give us 18. For these other isotopes, I will observe that I will have 37 minus 17, and this is going to give me 20. This is going to give me 20. Let me remove this long line. It's going to give us 20. What now, therefore, we now observe that. Good. Now, we now see that the phenomenon of isotopy is pronounced well. We can talk about isotopy and talk about the shortcoming of Dalton's atomic theory because atoms of the same element have varied number of neutrons. The same element has 18 neutrons, and then the same element with another atom has 20 neutrons. So their varying number in an atom now bring us to the concept of isotopy. In the next video, we will be talking about atomic number, mass number, and isotopy. Thank you very much, dear students. If the lesson was interesting to you, you can consider subscribing. Backward Phosphate Academy is here to help us work together. It's here to help us work together. I'm rounding up this lesson. Thank you so much. Bye-bye. Don't forget to subscribe to our lesson. Don't forget to hit the share button. Don't forget to like and share and subscribe. We are always ready to work with you one-on-one with our online classes. If you have any difficulty in any topic, don't hesitate. Contact us. We are going to be there with you. We'll help you to read the books. We are on the textbook. We are reading day and night, looking for all the different methods to help you become an expert in chemistry.